Let's see, I think we're okay. Welcome to our latest video on metaphysics, biochemistry, life. I want to cover, out of all the stuff I want to cover, and there's so much. Boy, it's hard to choose. So, let's see, can we see okay? Yeah. I think the next thing to talk about is something everyone has heard about, but maybe doesn't know what it is. Amino acids. I think everyone kind of has heard of this at one time or another. What are they? How are they used? Without a doubt, they are the building blocks of life. Without these, there is no life. Well, that's true of a lot of chemicals or a lot of different things, but nothing is more important. It's almost all that DNA deals with. So what we're going to do today is we're going to go through them. By no means you have to memorize or know these by heart. I don't. I got a sheet right here giving me the information I was putting on here. But yet, if you don't know what they are, well, first of all, amino acids. Well, I mean, when you eat, and all the protein that you eat, the object of your digestive system is to break the proteins down into the amino acids that make up the proteins, so that the amino acids can get into your blood system so that new proteins can be assembled using the amino acids that you have digested. The body is amazingly good at recycling chemicals, especially amino acids. There are two types. Essential and non-essential. Now, I gotta say this right off the bat. You may have heard the two terms, maybe. There's about 20 of them that is important for human life. They are all essential. But what in this definition of essential and non-essential, there's about 9 of them that are essential. In that, and they are essential in that you must take them in via food. Your body cannot make them. The other 11, which are no less essential to human life, your body can make from, well, actually I should say this way. It can make the non-essential ones from the essential. So these are the 9 that must be in the foods that you eat. And as we go through them, we'll say each one. I'll let you know what's essential and non-essential. There's actually supplements you can take. I take one. It's nothing but the essential amino acids. One of the best natural foods that contain almost all essential acids is eggs. If you eat eggs, you're doing very well in the non-essential, or the essential amino acids. Now, let's start here. We have oxygen and hydrogen. Oh, you can't see that. I guess let's start a little further down. You see that? OH. It's a hydroxyl, in case you forgot. That's attached to a carbon that's double bonded to an oxygen. This is attached to a carbon, which is attached to a hydrogen, and is attached to a nitrogen and 3 hydrogens. Actually, these 3 hydrogens are around the nitrogen. This is the backbone of amino acids. Every amino acid has this, no matter what they are. What determines the amino acid it is what's attached here. And I see we lost our focus. Hello. I think we got that. There we go. They can start, and what can be attached varies. Actually, biochemistry text will have an R here. And the R means whatever else. R can be anything. Okay? But now we're going to get into what they are. For example, the most simple amino acid is just another hydrogen here. This is a non-essential, and it's called glycine. Some of these names, as we go through these, you will have heard of at one time. You may, hey, I've heard about glycine. That you need that for for your nutrition, or to live. But this is the first. This is the most simple. Now we remove that, and we put here another carbon with three hydrogens. Remember, in the future, I'll just draw this as like CH3. See, it means the same exact thing. I hope you can see that. This is called an amino acid called alanine. Okay? That was a non-essential. Then you can have CH, with a CH3 attached here. Hold on, I want to make sure I get this right. Actually, that is incorrect. There we go. CH. Another CH3. Okay? Now, envision this as a carbon with three hydrogens around a carbon with three hydrogens around it. Now, it's starting to get a little more complicated, isn't it? This is valine. And is an essential amino acid. Eggs have a lot of this. And then we got CH2 CH with two CHs attached to it, like this. And this is leucine. This is also an essential. You must take this in. And if we do this, this is leucine. However you want to pronounce that. Also an essential. Then we have CH2 with an OH. This is called serine. All right? Oh, serine is a non-essential. Then we have CH, OH, CH3. And that's called THREONINE. Let's make sure it's got a focus. Yep. 309, I believe that's pronounced. You might think this, so what? All these different attachments make it a totally different chemical. You bet it does. Big time. We could have CH2 with a sulfur. This is why sulfur is actually, which is also an egg, by the way, is so important to your air intake, because sulfur is a part of several amino acids, of which this is one. Cysteine. But oddly enough, this is not an essential amino acid. The body can make this from other ones. And it can make it from this. CH2, CH2, the sulfur, CH3. ION, ionic thionine. Okay, so you can see how the other one, the attachments are different. So if it has, this is an essential, by the way. It all comes from eggs too, but you can see where it says it has a sulfur. The body can make the other sulfur-containing amino acids from this one. And then we have, they start getting a little more complicated. Let's do that. Okay, 4 of them. Wow. CH2, 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 CH2. And then NH2, a nitrogen. This is lysine. This is an essential. You must eat this. Oh, well then, I only didn't have to do that. They had 4, remember? This one only has 3. 1, 2, 3, then NH3. Remember the one I just did had 4 of the CH2s. This is OR. NITH. ININE. Ortho something. I deal with this stuff all the time. I'm learning, and I don't even know how to pronounce some of these. But you can see where the body can make this. This is a non-essential. The one previous was, because it had the 4 instead of the 3 carbons here, CH2s. So all the body has to do is take one of those CH2s off, and then it has this one. Yeah, see what the previous one was what? Lysine. That was CH2, NH3, NH2. So it takes this one away from lysine to make that. There's remember we talked about enzymes? There's an enzyme that does that. There's an enzyme that gets rid of that extra carbon and dual hydrogen when it needs to. This one's a little more complicated. We got 3 CH2s. Then an NH with a carbon double bonded to an NH. And H2. 2. This is argon. I guess you would pronounce this arginine. ARGININE. Remember, as you see all this is all within you. This is what makes you possible for you to live. That is a non-essential, by the way. CH2, CH2, carbon double bonded to an oxygen with an OH. Glutamic acid. But this is a non-essential. Well, I'm going to say this right now. The reason why this is so important, what's attached here? See, this is much more. If you have there's two terms we're going to learn in the near future called hydrophobic and hydrophilic. Hydro means water. Phobic means fear of. Philic means love of. When an OH, the hydroxyl, loves the water because that's mostly water is H2O. If a amino acid ends in CH3, it's no big. It has no big affinity for water, whereas OH does. Therefore, this substance, in this case, glutamic acid, will tend to dissolve, I guess is the word, more in water than does something that ends in CH3. Because this is more polar, has more of a charge to it than this does. And where that comes in so important is this the end charges that as these like if this has got plus charge or no charge, or if this is a slight negative, as these proteins are built, they attract each other or repel. And the protein, that's what causes the protein to have its shape. And the shape is everything as far as the functionality of the protein. Okay? One that was very similar, one that's very similar to it is CH2, CH2. C double bonded to an O. And just NH2. It's glutamine. Oh. A non-essential, your body can make it, and there's a great deal of this in you. This is a CH2, the C double bonded to an O, and then an OH, aspartic acid. Also a non-essential. And we don't have too many more here. CH2, C double bonded to an O, H2. This is also a non-essential. Asparagine. A non-essential. I think I already said that. Now they get a little more complicated. This could be CH2. Here comes, these are all carbons. There's that benzene molecule. Phenyl alanine. An essential. You must take this in. As in a lot of foods that you eat, but very, very important. Now, by just adding on an OH, don't you find that amazing? We just add an OH on the end, this becomes something totally different. In this case, it becomes tyrosine. Here comes one everyone knows. I don't know how many of these you've known or heard of. This one you have. CH2. Now I gotta try and draw this correctly here. I'm actually going to draw it off this way. I'm going to draw it like it shows here. N with the hydrogen. Sorry. Yeah, that's it. These are all carbons, by the way. I don't know if you remember all this, but that's the shape. And this is one you've heard of. TRY. Trip. T, you dummy. Tryptophan. Very associated with turkey. How many times have you heard people say they eat turkey on Thanksgiving? Turkey is by far the greatest source of tryptophan. There's other meats that do, but it's by far, the most tryptophan is found in turkey, or the most is found in turkey. And then they say it makes you sleepy. No, well, that's not true. It's true, but it's not. Tryptophan, though, is a precursor. I'll write that word down. A precursor. In other words, a precursor is something is made from. Okay? Tryptophan is a precursor of another chemical that I know you've heard of. Serotonin. Yes, sir. The serotonin. How many times have you... Serotonin has a reputation of being it's one of the chemicals in your brain. It's one of the feel-good drugs. When you do something that really makes you feel good or you're happy, and if you're happy and you know it, it has to do with your serotonin levels. Some people who have real mental problems have a lack of serotonin. But when you consume turkey and your supply of tryptophan goes way up, so does your supply of serotonin. Therefore, you got that kind of. I think a lot of people, I think that's one of the reasons. Thanksgiving is my favorite holiday of the year, and to me, eating the turkey dinner is just the best part of it. And maybe this is why, because when after you eat it, your tryptophan goes up, therefore your serotonin goes up, and you're just in a better frame of mind because of this additional serotonin that your brain has. So, just a little interesting side note. And finally, the last one I want to give you is this. Let's see. This is exact. I'm just going to draw it here because it's kind of hard to. Okay, let's do this. CH2. Kind of chances here, kind of. Don't worry about it. More or less. It's a little more complicated than that, but who cares? And this is histidine. Now, I stated earlier that amino acids are the building blocks of proteins, and they certainly are. Histidine, for example, is in many proteins. But there are other chemicals which the amino acids are the precursors of, like the tryptophan was for the serotonin. Histidine is the precursor for you probably know you heard of it, histamine, which is what makes you miserable and gives you a runny nose. And because what happens when you get sick, the histamine gets produced, and that's what causes you to have the runny nose and blowing your nose constantly, and it lets loose all the mucus generating glands in your body. And so there's a connection there. And I tell you this too, just as a side note, much of the over the market for like colds, for cold symptoms, where you take, because you got runny nose, you take something to block histamine, and therefore your runny nose stop. But something, your body is very smart. It knows what it's doing. The idea is behind the histamine is to get you to expel all that stuff. Okay, one of the things, especially if you get the flu, is the getting a fever. Well, guess and people hate that. I know I do. You get that that you're burning up, or you got a fever, but your body's smart because it knows that heat destroys the virus. The virus that's giving you the flu is destroyed by heat, body heat. So basically, it's turning up, your body turns up the thermostat to kill the virus. So there's times that get out of control, though. Once you get about above 106 degrees, your life is in danger. But because many proteins fall apart at 106 degrees. And your life will be in danger at that level for at that temperature for any length of time. All right, now that you know the amino acids, well, you know what they are. You know the names of them. Some of them. Who cares about? You don't care about how they're. It's just so that you can see what was involved. But they are the building blocks, and we're going. And the next video, we're going to talk about how proteins are made, how they're built, and the proteins that enable you to live, that do all your work. Oh, by the way, I forgot one. I'm sorry. Actually, don't worry about it. It's called proline. And proline is a major component of collagen. Learn how to spell, Frank. All right. What you gonna learn? Yes. Whereas each amino acid, and all those amino acids, by the way, are precursors for other chemicals. We just went through the main ones. I mean, that makes those amino acids important by how the protein. Probably one of the best examples of all the protein, is insulin. I think I've used that. Obviously critical, hello, critical to, for sugar and that type of thing. But in your pancreas, where insulin is made, in the DNA is the instructions how to make insulin. Here's a question. The DNA that is you, everyone's DNA, though I think about 99.9% of human DNA is the same between everyone. You, me, your brother, your uncle, your mom, your dad. But it's that difference, that 0.1, that makes us the individuals that we are. But the DNA that's in every cell of your body, doesn't matter if it's the pancreas, it could be the heart, it could be the lungs. The DNA is identical in every cell of your body. But yet only the pancreas can create insulin. Do the lungs, do they have the DNA? Is it in their DNA as in the lungs? Do they have the instructions how to make insulin? They sure do. They're never used. Not the ones in the lungs. Same thing with your heart. In the muscle, in the cells of your heart is the instructions how to make DNA, in the DNA, how to make insulin. It's never used. But we're going to learn. There's one. I think I'm going to go on. I think for the next class or next video, we're going to study the cell a little bit. What's in it? There's books yay thick just on the cell. But the organs, actually, they're called organelles. They're inside. The nucleus, where the DNA is kept. The only exception, I said, all cells. I just said a little bit ago, all cells have DNA. Not true. The ones that don't, there's some abbreviations I'm going to give you right now. RBC, red blood cells. Whereas white BC, or WBC would be white blood cells, which of course are part of your immune system. So when I refer to RBCs, you're going to know I mean red blood cells. Red blood cells have no DNA. Because they have no nucleus. They have just about everything else. Regular cells do, but they have no nucleus. Red blood cells last for about 120 days. So in other words, as of 120 days ago, you have, within the last year, you definitely have totally different blood. White red blood cells broken down by the spleen. Spleen actually has two purposes in life. It's meant to be like a reservoir for red blood cells, but also breaks down the old ones. And guess what? Recycles the amino acids that make up the cells, because they do wear out. You literally have billions of cells that are replaced every single day, with no exceptions. So, because I want to get to the cell, and the DNA, and how, I mean, the cell is much more than the DNA. Many times over. Okay? One of the things I hope to impress upon you is from a metaphysical viewpoint, the control, the exact controlling. What happens inside a cell is nothing short of miraculous. I can't think of a better term. I want to say it's a miracle, but it's incredible what happens inside each and every cell of your body every single moment of every single day. So I'm going to end it there, and that's what we'll talk about next time.